Hey guys, this is Naveen here. Welcome back to Naveen Automation Labs. So a lot of people were asking and getting confused that what do you mean by Stack Overflow problem? How exactly we have to fix this problem and what are the reasons that we are getting this Stack Overflow error, right? And what do you mean by stack memory? How exactly it is allocated and deallocated? A very important chapter in Java. In fact, almost all the companies, they will be asking you this interview question. Explain about stack overflow or explain about allocation and deallocation of the memory in a stack and how to improve the memory size. So let's see how to do that. So first of all, let's understand what do you mean by stack. Stack is a kind of data structure that we know which will hold the data on the basis of LIFO. LIFO means last in and first out. Exactly same concept is there in Java also. For example, let's say I'll do one thing that I'll create, this is my main method and this is my class. I'll create number of methods over here. For example, this is my first method. Let's see, M1 method I have created. And likewise, I'm going to create two more methods. For example, let's see M1, M2 and M3. And inside this M1 method, I'm going to call M2 method because I can call it where both are static, and then M3 call is done by M2. And inside M3, I'm writing, for example, system.out.println. And before that, let's see, I'm declaring one variable, which is I is equal to 10. And I'm printing I here. And then from the main method, I'm calling my M1 method here like this. So when you run this program, what will be the output? Java will go to the main method and M1 method will be called M1 to M2, M2 to M3. And finally, I equal to 10 and I equal to 10 will be printed on the console. So first it will allocate all the memory allocation for all these four methods. Okay, in the same order they are being called, and the memory allocation will be deallocated in the same reverse order, right? So it will create a kind of a stack inside the memory, inside the stack memory. So if you run this program, see, I'm going to run it, and if you see that I equal to 10 is getting printed on the console. Okay, so 10 is getting printed on the console, you can see that. Now let's understand that how exactly it is working internally. So to understand this, we need to understand the Java memory management system. So what exactly happens? For example, let's see, this is my Java memory. One is the heap memory and one is the stack memory. So this is my heap and this is my stack. The object creation part will happen inside the heap memory, and the stack is used for the memory allocation and deallocation for the map. So what exactly we have written? We have written that, okay, yeah, we have this main method. Main method is calling M1 method. M1 is calling M2 and M2 is calling M3, right? So inside the stack memory, there is one stack like this. And then this stack, the first main method will be loaded. So this is my main method. Main method is calling which method? Main method is calling M1 method. Under this particular M1 method, it will call M2 method. And then it is calling M3 method over here. And inside the M3 method, we have declared one variable integer I is equal to 10 like this. So here it is saying I equal to 10 here inside this particular stack. Okay, if M3 is also calling something else, then it will keep creating the stack. So stack means the last in and the first out. So there are two operations. First, we have to push the element and push the stack and then pop from the stack. So this is called LIFO mechanism. LIFO means last in, first out, right? So last in means who actually came last. M3 came last. So when the deallocation will happen, it will happen on the basis of LIFO. So the pop will happen when you get the value, the first value from this particular stack, M3 will be taken first. And when you fill it, what will happen? The main method will be filled at the first stack memory over here like this. Okay, so what will happen when you run this program? So we will come to the main method and then allocation will happen. Main method to M1, M1 to M2 and M2 to M3. So the allocation will happen like this, right? And then when I run this program, so what will happen? M3 got executed completely. So this stack memory will be deallocated. So M3 will be deleted, and then M2 will be deleted, and then M1 will be deleted from the memory, and then finally main method also will be deleted from the memory. It means we are doing a pop operation from the stack. It means this is called a deallocation. So first we are going to allocate like this, and then we are going to deallocate like that. So deallocate will happen in this order. This is called deallocation and this is called allocation, right? So everything will happen inside the stack memory, not inside the heap memory. Now, once this stack memory is completely, filled up, then you really don't have any space. It means you keep creating the number of stacks like that. It means then the stack memory, we don't have any space. The stack memory is suffocated, and then we don't have any extra spaces available inside this stack. So in that case, what will happen? In that case, you will start getting stack overflow error, right? Stack overflow is not an exception. Stack overflow is the error because of your stack memory is full. So for example, let's say you have only 1024 KB memory for a stack, and then just because of this allocation, that let's see in case of recursion, in case of back-to-back recursion that you are doing it, okay, let's see there are two methods, M1 and M2. M1 is calling M2 and M2 is calling M1 back-to-back. Let's see there are two methods, M1 and then again M1. This M1 is calling this M1 and M1 is calling M1. This is what a recursion you are doing it. So in this case also your stack memory allocation will happen up to the infinite time, and then finally once the memory is crossing 1024 KB, for example, in that case you will start getting a stack overflow error. So I'll show you practically. First I'll show you how exactly stack and everything will be created. So this is called the thread stack size. So let's see, this is the example that we have already taken, and I'll be running in my debug mode. So I'll select the debug mode from here, and then you see it over here that okay, all these stacks you will stack creation you will be seeing over here. So I'll do one thing, right click on it, and I'll do one thing, that I'll put a debugger at M2 at line number 6, at line number 10, and at line number 14, and at line number 19. And you try to observe the behavior over here, how exactly stacks are getting created. So how exactly the allocation and the deallocation will happen. So right click on it and go to debug. I'm using Eclipse, you can do it in any editor. So here you can see that, okay, yeah, can you see that the main method, Java will call the main method first. So here you can see one thread entry for main method got created, and then you can see the stack overflow concept, main one stack entry got created for line number 19. We are inside this line number 19 and this is one thread stack. Okay, then just keep running it. So then we are going to M1. So see, can you see that? So it's inserting on the basis of that. See, first main method and then M1 is coming on top of main method. This is not a queue. This is a stack over here. Okay, you can, I'm calling from M1, I'm calling M2. So it's coming inside M2, and one more stack entry got created for M2 over here. Then again from M2, I'm jumping to M3. Then you can see M3 got created over here. And under M3, there is a variable I. So you can see that, okay, for variable I got allocated is equal to 10 over here inside the stack. Okay, inside the M3. And then finally what will happen, it will print the value of I on the console. Okay, and then now it will start doing the deallocation. Memory deallocation will happen. It will start releasing the memory. So what will happen from M3, and then again it will come back to M2. So it will come over here at line number 11. See this. And then the moment I run in the debug mode, the next line, it will come over here, and you can see the deallocation will happen from here also. So here I'll just run it again, and you can see M3 entry got deleted, and it's jumping to line number 11. Now again it will jump to line number 7. So again it will remove this M2 entry from here. See, M2 is gone, and then M1 deallocation will happen, then go back to the line number 20, and the program is over, and the main stack entry also will be deleted like that. And then stack is again empty. So first it will fill the stack, and then that is called allocation, and then after that the deallocation will happen in that way. So that's why the stack memory allocation and the deallocation or stack memory management is quite easy as compared to heap. Inside the heap you have to create objects, number of objects that you have to create whenever you're using the new operator or any other ways of creating the object. Each and every object will be having their references over here inside the stack, and the memory allocation will happen and the deallocation will happen on the basis of garbage collector. So garbage collector will come over here, it will delete those, it will destroy those objects which are having no reference and the null reference. So the heap memory management is quite complex as compared to the stack. That's why for heap we need more size as compared to the stack, right? So let's see how exactly programmatically the stack overflow will come. So let's do that. I'll do one thing, that I'll go back to my project explorer, for example, and let's see, this is my stack package that I have created. Under this stack package, I'm going to create a class, and let's see, my class name is a class and having the main method, and click on finish. And then I'm going to create one more class, and let's see, I'm having the B class, and the main method is there. And then from a class, can I call B class main method? Yeah, B class main method is static in nature, so I simply call, let's see, b.main, and I'm passing, for example, null over there, because b.main is expecting one string argument. So let's see, I'm passing string array argument, I'm passing null. And then again come back to b main, and then I'm calling a.main method, and I'm passing null over here. That I can do it, right? Now what is happening if I run a class? What will happen? The stack will start creating the stack like this. So let's see this carefully. I'll do one thing. I'll go to b.main and debugger at line number 6, and then again debugger at line number 6 in a class also, and then go to the debug mode, and then let's see. So right click on it and go to debug as Java application, and then you see that here first it's saying I'm inside the a main. So one stack got created for a main, and then you keep running it. Then it will go to b main, right? And then again a main, b main, a main, b main. So it will keep calling to each other. A will be calling b main, b will be calling a main. And can you see that the stack is getting, okay, started filling over here. So when you keep running it, see this, a main, b main, a main, b main, you can see it on the okay, over here like that. So what will happen? There is a huge stack memory that you are taking up, and the deallocation is not happening. It means that's a problem with your code. We run it directly in the run mode and run as, let's see, Java application. See, I'll run it again, and then here you can see that there is a problem. It's saying that stack overflow error. It means your stack is completely filled up, and now we don't have any space over here. So what exactly happening inside the memory? I'll explain you once again. I have a class having the main method. I have b class having the main method, and then this is my stack. Okay, so first it will go to a class main method, then it will go to b class main method, then again it will go to a class main method, then again it will go to b class main method, and then it will keep going on like that. So it will keep filling the stack over here like that, and we don't have any space now. For example, the space was only allocated 1024 KB, okay, or let's see 1 MB, you can say that. So in that case, the entire stack is completely filled. It means this is the allocation is happening, and then we don't have any space left. So that's why now Java will say, okay, fine, then after some time it will give you stack overflow error. Okay, so here you can see that if I'm running in the debug mode once again, see debug as a Java application, and here you can see over here that, see, there are so many stacks got created over here. Can you see that? And after some time it will throw the error, okay, when you completely run it. So how to solve this problem? Okay, so this is one of the example. Second example is that you will be getting stack overflow whenever you are doing a recursion. So let's write a recursion basic program also. Either you are writing in the form of a factorial number, or let's say you are calling a function which is calling itself, that is a recursion. I'll do one thing. I'll just create a function over here. Okay. And I want to print some string 1000 times or 10,000 times or 100 times or let's say 100k times. So how will you do that? In this case, this method is saying, okay, fine, that I'll put one if condition here. And then I'll do one thing. I'll maintain one, let's see, one static integer counter, which is equal to 0 initially, or let's say equal to 1 initially. And then I'll put a condition that if this count is less than equal to what? Less than equal to, let's see, 1000 times. Then I'll do one thing, system.out.println. Let's see, I want to print hello 1000 times. Okay, and then I'll keep increasing the counter plus, and then I'll be calling this function once again. So let's say I'm calling print number once again. So this is what? This is called a recursive function, right? A function, it is calling itself. And then I'll make this method a static. If you don't want to make it a static, then you have to create the object of this class and then you have to call it. But let's see, I'm just directly printing it, calling this particular function print num. Now when you run this program, hello will be printed 1000 times. So let's run it and let's see, run as a Java application, and on the console you can see that, okay, hello is getting printed 1000 times. So here we are not getting any stack overflow, because whatever the memory allocated, the stack is maintaining up to 1000 times. So let's increase up to 10,000 times. Let's see it is still giving you the error or not. So let's run it again. And you can see that, okay, yeah, for 10,000 time also, hello is getting printed on the console without any problem. Now let's make it 100k times. It means, 100k means 1 lakh times. And when you run it, and then you will see that, okay, yeah, it is printing, and then finally it will give you Stack Overflow. My stack is overflow now. You can see this particular error over here after printing so many hellos, and then it will give you Stack Overflow error. So this is not an exception, first of all. Now what exactly some people they do it, okay, let's put inside a try catch block. That's a bad practice. You should never, because try catch is generally made for exceptions, and exception is coming because of the problem or unwanted conditions are coming in your code. But Stack Overflow is the problem, or fatal error or memory allocation error or something like this. These are the errors. These are the serious problem in your code. It means you are taking a lot of memory, allocating a lot of memory, and you are not deallocating it, and your stack memory is getting filled. So in that case, if you're trying to put inside a try catch block, it's always a bad practice. For example, let's see, I know that, okay, this print number or this entire if logic is actually giving me the Stack Overflow. And then I'll put inside the try, and then I'll try to catch with Stack Overflow and Stack Overflow error E, and then I don't print anything over here, right? And then let's see, I'll write system.out.println. I'll try to print by. So by will be printed or not. It will generate the Stack Overflow, but let's see, is it really handling or not? So let's run it and let's see. So here you can see that, okay, yeah, this time it's not giving you Stack Overflow because of the catch that we have written. But your stack memory is already filled up, guys. If you have the similar kind of code and you are calling some other methods also in your program, in your system, in that case, definitely chances are very high you will be getting a Stack Overflow error for sure, because your stack memory doesn't have any space now. So how to rectify this problem? So this is a bad way of doing it, guys. We should not try the try catch block. Okay, so please do not handle the Stack Overflow with the try catch. So let me just remove this try catch from here. And what we have to do is, when you run this program at the runtime, or when you design the system, if you see, okay, yeah, first of all, that there is a problem with this code that, okay, it will be called 1,000 times. So if you see the stack over here, so let's see, I'm just debugging at line number 12, and let's see the stack. So right click on it and debug as Java application, and then let's see how exactly the stack is getting created. So I'll go to my debug mode here, and then we will try to see the stack. See this? Okay, I'll just keep running it multiple times. Can you see that the stack is getting created? This is called the recursive stack, which is started from main, and print number is calling again print number is calling again print number method back to back. So it will create the stack these number of times. So obviously once the stack memory is getting completely filled up, in that case you will start getting the error. So see, I'll just keep running it. See, can you see the stack is getting filled? The stack bucket is completely filled now. So the deallocation is not happening here. So that is a problem with the code or the memory allocation issue, right? So in this case, how will you fix the problem? To fix the problem, what you do, you right click on it and run as run configuration. Go to the run configuration from here, and then what you do is simple go to, this is your print numbers. Okay. This is my Java class that you have to select, and then go to arguments. And from the arguments, in the VM argument, you have to pass certain arguments over here. Arguments, and then hyphen capital X SS. So capital X SS is used for stack memory allocation. That what is the memory allocation that you want to give. So for example, let's say the default 1024. So 1024 means 1 megabyte is already given. So let's say I'm writing 2 megabytes. So you have to write 2M over here. Okay, so minus XSS, and then you write 2 megabyte, and then you simple apply and then close it. And then you try to run and then check, are we getting the Stack Overflow error or not? So let's see. Let's run it again and let's see. So when you run it, still you are getting a Stack Overflow error. You can see that. It means the 2 megabyte memory also, 2 MB memory also is not sufficient for this program, because the number is so high, around 100k times. So I'll do one thing one more time. Let's see, increase the memory allocation. So let's see, instead of argument of 2M, I'll be passing 3M. Okay, it means 3 MB I want. So click on apply and then you close it, and then let's run it. 3 MB is enough or not? So let's run it again. See, it is absolutely enough now. So after applying to 3 MB, it's not giving you any Stack Overflow error, and I'm not handling with the try catch block also. It means now we have given the bigger size of the stack. So what will happen in that case? The stack will start getting created, right? And what is the total memory allocation that we have for that particular stack? So in this case, when I run my program, I have already given the instruction to the JVM that I have 3 MB stack memory, right? So first a stack will be created with the main method. Then it will call the second method, that is print number method. Then again it will call the print number method recursively, and then it will keep calling it. And then we have enough space like that. So it will call like that. The memory will keep allocating up to what, 100k times. And 100k times is getting handled within 3 MB stack size. So which is absolutely working fine. The default size was 1024 KB. It depends on your operating system, on your laptop. If you have 64-bit or 32-bit machine, most of the time it will be 512 KB for 32 GB and then 1024 for 64 GB, like that. So the moment I was increasing to 1 MB or let's say 2 MB, it was not able to handle. The moment I increased to 3 MB, it was able to handle that. So with 3 MB, the stack memory is completely okay. Still we have some space, and the 100k allocation got happened over here like that. So now this is absolutely working fine in that case. Okay. And then after 100k, it will start deallocating like that. It means my stack memory is getting deallocated now. So this is called allocation, alloc, and this is called deallocation, like that, in the reverse order over here, in this order, and allocation will happen in this order. Okay, and it will stack. So this is on which LIFO mechanism, it will follow that. Okay, last in, first out. Okay, so this is how we have to handle the Stack Overflow. First, you check your code, and if you have certain requirement, in that case, you have to increase the stack memory size. Then only you should handle it. You should not handle with the try catch block. Try catch block is just handling that particular error, but the memory is still there. The memory allocation is still there. The stack memory is still filled up. Okay, guys. So that's all for this particular video. I hope it is clear. What do you mean by Stack Overflow? What do you mean by stack? And then you can check one more video of mine that where I have already clearly explained what is the difference between heap and the stack, how exactly heap memory will be allocated, how exactly garbage collector and everything will work inside the heap, what are different spaces inside the heap. Inside the heap also we have hidden space, we have young generation, we have survivors. Okay, so heap is only made for object creation. So here you will get the objects, and the stack memory is allocated for your thread allocation, for your memory thread allocation. Okay, I hope it is clear now. This is a very famous interview question. Please prepare that. Don't get confused between heap and stack memory. Thank you so much. Thanks for watching Naveen Automation Labs. If you like this video, please guys subscribe to the channel, share with others. If you have any other important things to share, please feel free to share in the comment section. I'll definitely have a look. And then thank you so much. I'll see you in the next video. Till then, take care and God bless you all.